Hello, in this episode we are going to implement, um, essentially, we're going to enhance essentially our file sync. So it essentially actually writes to a file, right? And we're also going to make sure that it stays a very generic function. So we're going to implement trade bounds on essentially saving to a file. So how are we going to save to a file? So what we essentially want to do is we want to open a file here. We want to write the variable in binary format to a file, and then essentially we want to close the file on exit. So let's see Rust files. So how does Rust implement files? So if we see here, essentially is a nice example, right? So we have to include these two things, and then we can open a file, we can read to it, or we can write to it. So let's just do this. Let's use the standard library. So we are going to use it here. So let's create the file. Exactly. And we're going to call this bin data, or data.bin. Exactly. And what we see is, okay, we see an error we also had, let's say, in the previous times, and that means that we need to have essentially a fallable here, right? So how are we going to do this? We want to return fallable. And where are we going to find this? We are going to find fallable here. Okay, fallable. And at that point, we also need to, of course, specify what we are going to return in case of it's normal, like this. And now, of course, we need to also return an OK. Now we satisfy this. So we open the file, right? Now only create only, right? So maybe next time, essentially, we also have to check if it already exists, right? But this question mark will probably fail if the file is not existing. We see a warning because we don't use the file, so let's use it. So now we say, okay, file.write. So now we're going to write, and as you can see, it takes a buffer. Okay, so how? Now comes the question. So how do we take essentially a message, which is a receiver of a message, and convert this essentially into a binary format? For this, we have in Rust language, we have bin code. So let's see. Server bin code, binary encoder, decoder. So let's include this in our project. Copy it. Find our cargo. Bin code is included. And to actually serialize our structure, there's this brilliant library called Serialize, which uses essentially procedural macros to serialize any data type you can define essentially in Rust into either JSON or bin code or any other format. It's really nice thing. What we need to do here is very important because we need to use a derive keyword. So we need to enable that feature. So features is derive. Alrighty. Perfect. So now we have Serialize and bin coded. So now we can use it. So let's again check how we use Serialize. Rust. It's always nice to see an example. So we have this. We need to use serialize and deserialize on our data types, but also here for our type, right? Because now we are going to serialize this message, right? So what we're going to do is bin code serialize And as you can see, it takes a value which can be any sized, let's say, which can be any essentially value, and it will try to serialize it, right? So essentially what we're going to do here is serialize the message. Okay, so it needs to borrow, and now you can see he complains because now it says, hey, you know, there's one trait bound that is not really satisfied, and that's the serialize. So let's add this to our serialize trait bound, and here we also need a borrow. Of course, we need to check the outputs. So we covered essentially the question mark parameter in a previous episode. What this essentially does is, if it's okay, it returns the value, and if not, it just leaves essentially the function with an error. And this is essentially the same principle. So essentially what we say is, okay, try to serialize it. If there's a problem, just leave. And if it leaves, it means also it's going to close the scope, it's going to close the file, it's going to close essentially the channel, and it will all have consequences to our other essentially async agents that are writing to it. So this is something to take into account. But so now essentially we have implemented in a very quick and dirty way, a way essentially to serialize binary files. Now, if we compile, we will probably get error messages because what I believe is that our message, which we're sending now, so because we're using the file sync, doesn't implement serialize yet. So I'm already going to copy it. We're going to compile, and yes, what we see here is it deduces it from the types and the trait bounds that serialize is not implemented on message. So let's search where we define message, use message. Let's jump to it. And here we are. So now we need to have a serialize and deserialize here. So let's just up and put it here. So like that. Okay. So now we've done this. We have an undisclosed delimiter. So what happened here? Of course, I removed this thing. And there we have it. We have like a very general implementation. So let's execute it, our function, and as you can see, it's still working like a charm. But now with a very general file sync, which we can reuse for different kinds of stuff. So let's clean this up a bit, right? Because this doesn't look good. So let's just make this into debug. And let's use it. Use. Okay. Like this. Okay, what I always like to do is put the standards above, then the more general to more specific. Failure, specific, and then we have Tokio. Okay. So let's commit this. So let's check. What did we do? We added 3 libraries: failure, bin code, and serializer. We adapted our file sync into very more generic, and now actually we save something to a binary format, right? And of course we have a message where we added the serialize statements. I hope this was informational. In the next episode we are going to continue on making the system more like an agent system. So essentially what we're doing is we're starting with a very specific implementation, learning the patterns, and then essentially abstracting it more and more until maybe we end up essentially with a reusable agent system, or we can extract some reusable patterns out of this process. So thank you for watching. One thing that's maybe nice to check is to see how our data file actually looks, right? So let's see. Here we have data bin. So let's open it, and yes, we can see it's like a very short file which stores 20 messages. Dump data bin. So it's like a very efficient way essentially to store 20 messages in 172 bytes. So, but again, thank you for watching, and speak soon.